Hello, 108 class. Mr. McHugh back here with you to start section 8.5. We are going to multiply and divide radicals. Going to take care of page 1 here. And so, good news, we're kind of into some familiar ground. We're going to be multiplying binomials that have got radicals. So we have multiplied parentheses times parentheses, aka binomial, two terms, binomial times another binomial. Binomial's got two terms inside it. And the technique we use is what? Hopefully you see my letters over here and you remember in first, outer, inner, last, FOIL. Okay, so take this first example here. 7 times the square root of 5 is the first. The outer would be, I'm running out of space here. I'll try to go up like this. 7 times square root of 2. Inner would be negative 3 times square root of 5, which is negative 15. Finally, last is negative 3 times 2, which is negative 6. Okay, so you ask yourself, can you combine anything? The answer is no, and you're done with that. So we're going to just use basic FOIL on the problems and just take care of the radical properties. So, but what's interesting is look at B here. I've got learn this or use notes to match the form. Let's analyze this for a second. So I see a binomial 10. Square root of 10 plus the square root of 3 multiplied by, now tell me what the word is here. Okay, what's the difference between the first binomial and the second? They're what to each other? Hopefully you're saying conjugate. Notice how the exact first terms are the same and the second terms are the same, and the only difference is the plus and a minus sign. Okay, so you're multiplying a binomial by its conjugate. Okay, now can you always fall back and use FOIL? Yes. And when you start the FOIL, and here the letters line up, square root of 10 times square root of 10 is square root of 100. Outer, square root of 10 times negative 3 is negative 30. Inner, 3 times 10, square root of 30. And the last, square root of 3 times the negative square root of 3 is negative square root of 9. Okay, simplify. Square root of 100. 10. The outer and the inner do what? Cancel out. Square root of 9 is 3. You have 10 minus 3. Final answer, 7. Okay, so that's interesting. With these radicals, and you have a binomial here and a conjugate, it reduces down to a number. Okay, so I was hoping for you to see the shortcut here was FOIL works, but you have the difference of squares. And so you could take the first term, square it, which is the square root of 10, square it, minus the second term and square it. Square root of 3, quantity squared. Okay, what happens whenever you square a square root? They negate each other. Okay, of course you've seen this. If you took the well, they negate each other. Squaring and square roots undo each other. 10 minus 3, there you go, there's the answer, 7. Okay, so try to remember that's a nice shortcut if you see that. If you see a binomial with, now you gotta have radicals in both the first term and second terms. Okay, gotta be very specific. So you might remember the pattern and use it when you see it, or of course you can always fall back and use FOIL. Okay, now I'm looking at example C here. And I'm going, oh, they took a binomial and they squared it. Okay, what you could do is expand that out, use FOIL, and go through FOIL, and you guys can kind of get the gist of this. Here's your first, there's 49. Here's your outer, 3 times the square root of 7. Inner is negative 3 times the square root of 7. And finally, negative 3 times negative 3 would be a plus 9. Notice the outer and the inner are the same terms. You double it. So you end up getting square root of 49 is 7. Double negative 3 minus 3 is negative 6 square root of 7 plus 9. And 7 plus 9 is 16 minus square root of 7. Okay, you could use that, nothing wrong with it. If you remember you've got a perfect square trinomial, you could do what? Let's see if you remember it. Take the first term, which is square root of 7, square it. Multiply the two terms together and double. Hopefully remember all this good. Take the second term and square it. So you got the rules, you've used them, you just got to deal with the square roots. Again, squaring, square root undo each other, you're left with 7. Double, negative 6 times the square root of 7 plus 3 squared is 9. Get the same answer. Okay, so keep that in mind. turn around and see a problem like this here. I see the difference of squares. You see a binomial and its conjugate. So take the first term, square it. Take the second term, cube root of 3 and square it. Okay, so now you got 5 squared is 25. Then over here you got to watch this little bit of extra work here. You've got, I'm going to use the right hand rule and rotate. I'm going to put the 2 underneath exponent, so I've got 3 squared is 9, so you've got the cube root of 9, and there's your answer. Okay, so cruising along here, objective number 2, we get into a situation of what happens when in your denominator you end up with a radical. And so this problem 2a that I've got here is 3 divided by the square root of 7. That's the original problem. Okay, now this is kind of like what you got to do is you got to remember this is a protocol rule. This is kind of like how we don't care for negative exponents. We have to deal with them and put them in the right format. Okay, the right format with the radicals is if to be in correct simplifications, and it's on the beginning of the chapter in the book, sir, in section 8.1 or 8.2. I talked about it, listed it. You cannot have a radical in the denominator. Okay, now you're like, well, so how am I supposed to deal with it? Well, the reason that how you deal with it is you realize this phenomenon. If you take a radical, multiply it by itself. Now we're talking square roots here. Square root of 7 times the square root of 7. Now I set it up here. Just watch what happens. 7 times 7 is 49. The square root of 49 boomerangs back the radicand, which was 7. Okay, now so that's the technique. But before you complete it, you don't just willy-nilly multiply by the square root of 7. You've got to stack the square root of 7 because anything divided by itself equals what, class? 1. There it is. There's the note right there. So this is equivalent to 1. So you're not changing the radical expression over here, 3 divided by the square root of 7. But when you multiply it by square root of 7 divided by square root of 7, it allows you to multiply across the numerator. So there's 3 times the square root of 7. And like we did down here, the driver is to get the denominator, the bottom, radical free. So you get 7 times 7, square root of 49, and there's your answer. Okay, hey, we've done it. We've got one page done. This is a common technique here, so get ready to see this. Just remember, we do not leave a radical in the denominator. Okay, Mr. McHugh here. I'm going to sign off here on page 1, and I will see you for page 2, where we'll continue on our work on multiplying, dividing radicals. Okay, bye-bye.